let's sketch some inverse functions. So when sketching an inverse function, you always start with drawing the mirror in which you will be mirroring your graph of the original function. And then you take points on your graph and try to find mirror points. So for example, any points of intersection are very convenient because those points do not move. They're mirrored. They're already on the mirror, so they're mirrored to themselves. So, okay. And then, for example, this point here, -2, 0, that will get mirrored into the point 0, -2. And then you join the dots. You could take a couple of more points. For example, this point here on the y-axis will get mirrored to a point on the x-axis. And then just connect the dots so you'll get something like this. Always check that it does look like a mirror image. So here we get this as a result. Same thing for part B. First draw a mirror, then find the mirror points over several points. For example, this has as mirror point again 0, -2. This has as mirror point -1, 0. And let's see, so this point gets mirrored to itself. So what we get is that this part of the function gets mirrored into this piece. And the second part of the function gets mirrored in this piece. And the red one is the graph of the F inverse. So this is F inverse of X. So let's move to the next problem, which means let's see if these functions have or do not have an inverse. So part B and C are actually easier, and let's do them first. So this has an x squared. So it does not pass the horizontal line test. It does not pass horizontal line test because, for example, f of -2 is equal to f of 2. So 2 points are going to the same value, and therefore it cannot be 1-to-1. So this means function not 1-to-1. Function is not 1-to-1. Same reasoning applies to part C. Because of the absolute values, we'll find two x's that go to the same value. For example, if you take x equals, let's say, so I want an x that will give me the same expression. So I'll need two x's that go to the same value. So I want x1 and x2 such that absolute value of x1 plus 2 is equal to absolute value of x2 plus 2. So for example, okay, let me see. The easiest thing is to draw this function, absolute value of x plus 2. So that's a shift to the left by 2. So I have this. And for example, if I plug in 0, in here, in this function, I get 2. And if I plug in -4, I also get 2. So I will have that f of 0 is equal to f of 4 for this function. So function in part C is not 1 to 1. We have found two values that go to the same value. Two values of x that go to the same value when plugged in the function. So function is not 1 to 1. Part A is a 1 to 1 value. It's a 1 to 1 function, and it does have an inverse. So let's see, how do we find the inverse for part A? First, we put in evidence where is y in this expression. Y equals 1 over x plus 2 minus 1. Then you switch x and y. So you get x equals 1 over y plus 2 minus 1. And then solve for y. Solve for y. So we move -1 over. So we have x plus 1 equals 1 over y plus 2. Then we multiply by the denominator. So times y plus 2. So we get x plus 1 times y plus 2 equals 1. Then we divide by x plus 1 to get y by itself. So we get y plus 2 equals 1 over x plus 1. And last, we bring this constant positive 2 to the other side. So we get y equals 1 over x plus 1 minus 2. And this is the expression for the inverse function in this case. And that's the final answer.